Okay, thank you. Thank you, Ricky. Um, so I'm Natalie Marlaney. So I'm a developer and I'm a co-founder of GitLab. Okay. Um, so we've built an all-in-one AI coding platform with Git repos and real-time collaboration, AI-assisted coding, and one-click deployments. I'm quickly going to show you. So this is desktop. So kind of the deploys tab. Um, so say, for example, this application here, conference Wi-Fi, and it's deployed. And this is what it looks like on mobile. We're sort of mobile first. So it's sort of, this is what it looks like to commit on our platform. And we built this all ourselves. And I'm going to sort of tell you a bit more about that. Okay. Um, so I'm going to talk about our journey of building a next-gen real-time Git hosting platform. So expect me to mention durable objects a lot, since they're a core building block of any real-time app built on Cloudflare, including our own. Um, so we're in like the process of going live, and I briefly wanted to reflect on the market that we're going to be entering into. So we're positioning our product to compete with the products of some of the fastest growing startups in Europe, and the world. So Lovable, Bolt New, Replit. This is the arena we're entering into. This is who we're competing against. So whereas most of our competitors are pursuing a top-down strategy, so they're starting from the prompt and moving to the code, we've gone the other way around. So we focus on strong engineering fundamentals and we're pursuing complete vertical integration. So we have no dependencies on anyone, not even GitHub. Um, so before discussing the crux of this presentation, I want to introduce a theme that will weave itself throughout and one that we care deeply about, and that is the idea of good system design. So, as a small company, it goes without saying that our goal is to be successful and to grow fast. And as a tech company, we strongly believe that good system design is essential for achieving that. So, in our mind, good system design, it's hard to achieve. This sort of mantra of simplicity ain't easy. I see it around everywhere in Cloudflare. Um, it's often hard to define. It's one of those things that you know it when you see it. And we think it's exceedingly valuable, and we would consider it as a moat, in addition to a few other factors like shipping velocity. It often results in secondary benefits that the designer didn't even intend, and sort of this will come up throughout the talk, and we call these free features. And then often it has completely unintended use cases. So you end up finding, I can use this everywhere. Um, so I have two goals with this talk. I want to try and convince you that durable objects are a remarkable example of good system design. And then I'm going to talk about how we achieve good system design. Okay, so let's dive into the components for what we've built for GitLab and what we're most proud of. So here's the list. So POSIX compatible file system in durable objects. We've put Git in durable objects with the help of libgit2 and WebAssembly. There's a serverless Git server with libgit2, which, according to the well-informed Git insider Ed Thompson, hello Ed, GitLib has, it's either 3 or 4, but we're the only implementation of a Git server amongst a cohort of 3 or 4 others in the entire world. We have a powerful and repeatable WebAssembly build pipeline with Nix. And we have a multiplayer file system, so durable objects, YJS, WebSockets, and then there's everything else, which includes like backend services and front end. So durable objects have been a direct inspiration for 4 out of 6 of these. So 1, 2, 3, 5. And all of these are mostly originally unintended use cases for durable objects. Okay. So let's zoom out a moment. So if you ever look for advice when building a new app, you most commonly get told, don't worry about scale, pick something boring. And I think this advice is mostly wrong. And why is that, you might ask? So it's because I strongly believe that good system design is upstream from easy scaling. Or in other words, easy scaling is a consequence of good system design. And easy scaling is notably one of the defining characteristics of durable objects in particular, and Cloudflare workers in general. So this means if you try to avoid scaling at all costs by prioritizing being boring, there's a chance you'll miss out on all of the other benefits of good system design in workers. And I'll list a few we've discovered for ourselves. So there's the incredible DX. It's lightweight and straightforward. We love Wrangler. There's a deliberate separation of compute and storage. So it's very reminiscent of functional languages. There's powerful composition, so RPC magic via service bindings, and high shipping velocity. So if you ever wonder sort of, why is Cloudflare shipping so fast? Let me you in on a secret, which is, well, I think they're building on workers themselves. All of this makes Cloudflare workers one of our not-so-secret weapons in our tool belt. And to be honest, I love it when I hear that our competitors are choosing not to build on it. So, gracias, guys. Okay, so let me take a deep dive into the main component of our system at GitLib. So our WebAssembly-based and libgit2 powered serverless Git server. So what's notable about it? Well, it runs on durable objects. We don't manage servers ourselves, thank goodness. There's the scale. We can have arbitrarily many of them. There's the performance. It works well for the huge majority of code bases by only utilizing one thread and 128 megabytes of memory. The size, it fits in less than 1 megabyte, so latency is very low. And it's portable to other JavaScript environments, most notably browsers. And then again, reflecting back on good system design, it still fascinates me that this works as well as it does. Durable objects are a storage product that I'm sure was intended as an application level storage. But it turns out it works so well as a block device, also suitable to be used for a file system. So moving to the other parts of our infrastructure, I'll let you on to another little secret of ours that I'm surprised not many people are talking about. So you know how Cloudflare workers were originally built entirely on the Fetch API? They made Fetch happen. So today, there's also the RPC interface, which is even more powerful. But just thinking about the Fetch API for a moment, one of the massively underutilized aspects of the Fetch API are the streams. So, if utilized correctly with workers, streams effectively make your entire infrastructure a sort of pipeline for weaving data. And for many tasks, if using streams in workers, you can achieve what you want to achieve without storing your data anywhere, not even in durable objects, KV or R2, but just having it flow through workers and transforming it appropriately. We do a lot of cool stuff with streaming in GitLib. So, for example, we pass streams across service boundaries as an efficient data transfer mechanism. And this way, we ensure that no worker buffers too much data, and this way we get amazing performance. There's multiplex and demultiplex streams. We concatenate and split them, and transform one file format into another while streaming. So, for example, we streamingly transform tar.gz into multipart form data. So in our infra, these cool techniques have many amazing use cases that eke out every possible amount of performance out of the worker's runtime. So here are a few examples. So one is initializing an editor in GitLib. So in our infra, this is a streaming operation that pipes a tar.gz archive from our Git server straight into one of our editors. So when you're committing to a repo, it's a streaming operation that pipes a tar.gz archive from our collaborative editor straight into our Git server, which consumes it and creates a commit out of it. Copying anywhere from the web is a streaming operation that decomposes a streaming tar.gz file and then extracts only the relevant operation. And then diffing repo to repo or repo to editor, or even editor to editor, is again a streaming operation that involves two archives, a multiplexing and demultiplexing. And at least some of the above features were unintended. We didn't set out. And we're of the opinion that this is an indicator of good system design. And it went from the Web Standards Committee to Cloudflare and finally to us. There was a chain of good design decisions that needed to happen for this to be the case. So another underutilized superpower of Cloudflare workers, and including durable objects, is the fact that they are such a good environment for running WebAssembly applications. So why is this cool? So WebAssembly offers amazing performance, but it also allows you to leverage a massive amount of powerful native libraries that have been built across decades, even before the web became as big of a platform as it is today. So for example, we compile and link many native libraries into our WebAssembly binaries. So to name a few, libgit2, zlib, libmagic, and libarchive. So here's a cool technique that we needed to employ while running WebAssembly programs, specifically in durable objects. So we started out running our WebAssembly code in durable objects by instantiating WebAssembly programs on each HTTP call. This worked fairly well until we needed to use the WebAssembly program to process messages from WebSockets. And then after careful deliberation, we decided to rework our infra to instantiate our WebAssembly program on durable object bootup instead of on every HTTP request. So this not only makes it possible for us to use the WebAssembly program to handle WebSocket messages, but it also makes our WebAssembly usage more performant since we don't constantly initiate teardown WebAssembly. So even though it's straightforward, employing this technique wasn't entirely simple, seeing as we needed to ensure that our WebAssembly program instance carefully releases any memory it took on each invocation. C, being an uncomplicated and pragmatic language, makes this easier. And also Valgrind helps a lot by detecting anything that a careful review misses. And then something very worth mentioning in passing, if you intend to use WebSockets in durable objects, which is very easy, you lose nothing by using the WebSockets Hibernation API, which is a Cloudflare-specific API, instead of the default WebSockets API. So the WebSockets Hibernation API is really simple to use and can only benefit you. And by putting your durable object to sleep while clients connected to it are idle, is a very cool money saver. So while we were busy building our product features, Cloudflare very helpfully upgraded durable objects underneath us. So we were surprised, some might even say shocked, to learn that our repos and editors became agents. And they're now both MCP clients and MCP servers. I think this is where I put this joke in. Okay. We still have to work out the full implications of this, but it does seem that this allows us to more easily build agentic coding features, which seems to be a very popular feature amongst our competitors. And so this has been a clear signal for us to kind of move in this direction, and that's why we're doing it. So the most sophisticated part of our infrastructure is our multiplayer file system in durable objects. So conceptually, it's split into two parts. So DOFS, which can be utilized through POSIX syscalls, and then YFS, which can be utilized through YJS operations. And at the core of this file system is an implicitly defined state machine that syncs between the two. And again, after building this, we were again surprised to see that this works as well as it does. We needed this functionality to enable collaborative editing within our Git repos. But after building it, we realized that we can also use it to enable broadcasting of coding sessions. So think Twitch, but specialized for programmers. And this is another example of a feature that we're getting for free due to good system design. And just to quickly mention composition. So I think it's an insufficiently praised feature of the Workers platform, and it's mainly enabled by the service bindings and the Workers RPC. And it allows assembling powerful components into an even more powerful system. And it's a true example of a time where the sum is more than I forget the phrase, but like 2 plus 2 being greater than 4. You know what I mean? So, to conclude, if you want to build a next-gen real-time app, I would advise to start with durable objects. Occasionally, you can encounter a sentiment that durable objects are not easy, but we personally have to disagree. And in my mind, to understand and truly grok durable objects, it's very helpful to see them from multiple different perspectives. So here's a few I find compelling. So for example, a Cloudflare worker and transactional storage. Maybe see them as the ultimate primitive for building more complex, strongly consistent storage products. Maybe think about them as a mini computer, an AI agent, and MCP server, and an MCP client. So the RPC interface introduced a massive quality of life improvement to workers and durable objects, and it's worth using it from the get-go. And it's a bit funny, on X, I've read many accounts of people going through what I would call durable object enlightenment. So there's a pattern which repeats, where sort of firstly a dev tries durable objects, and then the dev understands them. And then finally, the dev starts seeing use cases for durable objects everywhere. So to conclude, GitLib, we're launching. Thank you. We support AI-assisted development in the browser with integrated Git repos and collaborative editing. Our loud launch will be next week. So please give us a try and let us know what you think. Thank you for listening.
Thank you, Natalie. Thank you, Natalie. Oh, this Joe no mic. Goodbye. I can be loud. Thank you, Natalie. That was awesome. I wish my slides looked as good as your slides. Like those are like the best looking slides I've ever seen too. So, up next we've got Steve, fresh off a Series A announcement. So
Hey.
congratulations.
Thank you. I'm gonna try and move this a little bit closer. Hopefully it doesn't unplug itself. Can you hear me? Good. Cool. I am Steve Ruiz. I'm from Tealdraw, founder, CEO for what that means for a team of like 15 people, but yes. And I'm gonna be talking about Tealdraw and our kind of collaborative backend. And I'll be honest, the if you know Tealdraw, you probably know us from like some of the AI projects that we've made. And this stuff tends to be a hmm, it tends to be, when it works, better uh better demos than this, right? Like we have these crazy workflow type of stuff where we're running language models behind the scene and making these crazy graphs and stuff like this. This is the type of stuff that we tend to this is terrible. Nothing's working. It's like live coding, but with but I'm not going to talk about this yet until or unless I run out of time, in which case I will, or run overtime. Uh, TealDraw is a whiteboard. It's free, tealdraw.com. It's also an SDK for building whiteboards and whiteboard-like things, um, such as those other projects that I just showed. And that is at tealdraw.dev. If you're ever building something that needs a whiteboard or you have an idea to build on top of this type of stuff, you can do that, tealdraw.dev. The There we go. That's outside. We're using tealdraws here for the slides. Things that are special about tealdraw, a lot of little details. Um, Whiteboards can be kind of like not such a joyful experience to use unless someone's really paid attention to the details. In which case we have, or in this case we have. So we have like these nice little arrows. We have perfect freehand ink that is like variable width. The arrows stick to the ink as well, so they have this nice ink. It goes nice. Um, this is actually really hard to use with this little lip right here. It's right on the wrist. Multiplayer. This is multiplayer. If normally I could share a QR code, but don't do it. Don't do it because I because I've done it before, and I know you all look like lovely people, but one of you is going to draw something bad. So let's pretend you're lovely purple person here, and you're using Teal Draw, and you want to share it with someone else. Uh, there's kind of two elements of this. There's your experience of this, what you perceive to be happening, and then there's what's really happening. And the kind of the mental model of collaboration should be like, I'm me, I have my friend. This is the friend. I just want to kind of like work on the same project together. I want to be together working on this stuff, right? But there's only one project, right? I just want like in um in collaborative editing, I just want to be together on this. But we know that that's not really the case because whatever, unless you're reaching into the same laptop or something like that, it's not going to work. So you need to have these um, two separate experiences that are just mapping onto each other completely. They should seem like you're editing the same document, even though we know there's actually two documents. Uh, how that works? Well, how that works should feel like this. It should feel like, well, I'm making changes, they're making changes, and we're both sending them to each other, and then now we're adding up to the same document. And there are some technologies that will let you do that, but there are problems with that. Who's the boss? Who is the authority for what the document is? What happens when there's disagreement? How does that get resolved? You can only kind of solve that so far, and if there really is only peer to peer, the way that you solve it can be burdensome. I would say it can involve a lot of data. It can involve a lot of like validation of that data. It's a little bit impractical. Migrations are terrible. Things like that. So in reality, you want someone else. You want maybe like a server or something like that. I give it a goatee. And you want, but this no one wants to know about this. No one wants to experience this. There shouldn't be. This guy should be kind of like off screen somewhere. But in reality, and this stuff needs to happen. You're not talking to each other. You're talking to the back end. You're talking to the authoritative server who is deciding, is this change valid? If it's not valid, then here's some information that you use in order to roll back. If it is valid, then I distribute it to all the members. Um, in Tealdraw's case, this guy is actually this guy who's sitting over there, David, who wrote that engine right to do that. That's the only time I'm going to use your photo, David. Thank you. We'll stick with our goateed server administrator here. Um, and that's the way it happens, right? Most of the collaborative experiences that you have are talking to an authoritative server, which is kind of controlling the true document, and you're just getting your own temporary view of that document that you're editing, and those changes are going up and so forth. And if it's done right, which in our case it is, thank you, David. Uh, Everyone should have the same document eventually, right? This idea of eventual consistency is a word you hear a lot in collaboration. Um, but there are problems. As good of your as your backend is, if you have a lot of clients connected to it, um, it it's just work. The individual node kind of can get a little bit overloaded, right? Because it's shuffling messages back and forth. It's resolving things, right? If it's a certain node process living, somewhere in the world, at some point there are enough of these things, that this guy starts to like, sweat a little bit and maybe even get a little like, sad as he's trying to keep up with the traffic and the amount of requests coming in. Nodes get hot, you might say, right? You can solve this a little bit by having regional, servers. Like if you're playing video games, collaborative multiplayer video games, you'll have whatever North America or Europe or Australia, and then even within that area, you can kind of balance the load between different servers. But has anyone in the room ever written or implemented that kind of load balancing for collaboration or anything like that? It's bad. Sunil Pai is the one who could tell you more about this, but it's really, really, really hard. It's like not in it's one of the harder problems in just software in general. So we don't want this. Ideally, we want everyone to have their own little guy. We want everyone to have their own little server. Someone who's dedicated just to that instance, that room, uh, and however many rooms you have, you just scale it out horizontally. Everyone gets their own little server. Every room gets their own thing, and they have no dependency on each other. It's all the same or all individual, independent compute, messages, all that stuff, right? No matter how many people are in this room, doesn't affect the experience of the users in that room. Even though they don't know about the backend, it should just feel transparent because again, the experience that we're trying to replicate, the trying to tell people this is what's happening is, well, is this, right? This should be what it feels like, that you're working on the same document. It's fast, it's instant, whatever. There's no there's no way to tell users, hey, your document is slow, your experience is bad because something else is happening in a different room, in a different experience. Uh, but how do you do that? You can't have individual node servers everywhere. For that, you really need something like Cloudflare Workers. And I say something like, even though there really isn't an alternative right now, that idea of having a on-demand, small, encapsulated bit of compute that can uh, talk to clients and that has persistent sort of like memory, right? Like a runtime that doesn't die as soon as it's sort of invoked. That is an incredibly special thing that we get with Cloudflare workers and in particular durable objects, because the durable object is that persistent thing that is running. Um, I've already had like people tell me that my mental model of how a durable object works is wrong, but that's the way that I think of it. It's like a little server that has its own compute and its runtime, but it can wake up and fall asleep and come on and off and be there when you need it, and it can talk to external. For instance, in Teal like we just persist out to a database, normal database. Um, but we're keeping everyone in sync using WebSockets. There is a problem though that normally affects uh, this type of thing, where I just want to talk to basically this is the unit of collaboration, but oftentimes the server itself is far away. Sometimes it's US East, sometimes it's US West. If you're lucky, then there is this sort of regional stuff, but you don't want to be talking via this thing that's far away. So no matter how many of these we have, if they're all far away, it's not really as useful. It's going to lead to latency. It's going to lead to a little bit of lag. Um, but again, if the Cloudflare is on the edge, like it can kind of do this. You're going to see my arrows break in a second. I meticulously developed arrows with Cloudflare. When you connect to a worker, when you connect to a durable object, it's going to try and put it as closest to you physically as possible. When I'm doing my little demos of TealDraw, the server in our case is like, I don't know, it's like by Heathrow, or it's called Heathrow, but it's probably not. It's probably even closer. It's probably like a couple of blocks away or less than a mile away. And so you get that kind of like sub 20 millisecond latency and all that stuff. Now, the real magic of which I'm told is on the horizon, right? Is where you have, let's see, I have another guy over here. Is where you have moved the server close to these two people, uh, and then you have someone else join, maybe from like Brazil, something like that, who is down here. And the thing that we're waiting on that I'm very, very excited about is the idea of moving actually the process, moving the durable object to wherever it needs to be so that everyone is kind of triangulated into the same distance from that server so that you're getting the best experience you can for whoever's connected and for that to be live and updated and an uninterrupted experience for all the people involved. The reality is that most of the time the collaboration, even if you're in London and the worker or whatever is in California, is fast enough that people are happy with it. Um, but it's also fast enough that people are only happy with it because they haven't really experienced anything better. And when you have, I don't know, the demo I do is normally like two cell phones that are both connected to TealDraw, and like you can, which actually I think now that I think, well, maybe I can. If I go into this and I do this, right now I'm logged out, so I'm going to collaborate with myself here. Or this is I'm winging it, so we'll see if this works, right? So this is my mouse. It's not locally connecting. This is going to the server and coming back, but this is the latency. Yeah, it's like right on, right? Yeah. And that really, really, really matters because there are certain things that people do in a collaborative environment like this, which, if there's a tick, you start to lose it. For example, if I wanted to draw attention to this thing or whatever, or maybe this guy, one of the things that people do all the time is they wiggle stuff. They just kind of do this. Now, if you're on a tick, you miss that. If you're only committing the permanent changes rather than the ephemeral changes. So if instead of showing this move across until I dropped it, if it only showed the before and after, the kind of here and here, you'd miss the wiggle. You need the wiggle. You need these sort of like ephemeral throwaway events. Otherwise, information is lost. And that in this environment, it's all about whatever uh, ephemeral stuff, human stuff, whatever it means to us as collaborators. Um, that is how we use durable objects. And that is if I'm making a pitch for the company hosting this lovely event, like that's why you might use these for collaboration. They scale horizontally. They are fast. They're co-located or at least near to the users who are using them. Uh, they wake up, they fall asleep, they persist, they whatever, and you can use them as if they were just this like magic server that like oh, wouldn't it be great if everyone had their own server or something like that, and that server was next door. You could just treat it like that, it's really quite special. We've had a lot of luck and good times using it. Now my question is, how much time do I have left? We have 10 minutes for questions. Perfect. All right. Get me later for the AI demos and stuff like that. Cool. Do one AI. One AI? All right, one AI demo. Okay, so speaking of magic stuff that you wish kind of existed, like my background is a designer, interaction designer. All the time I would be making mock-ups that kind of look like this, where it's like, here's how should work, right? And the idea would be to communicate to developers that I was working with, here's how I want it to work, right? So if you're a developer and your job is to work off of my designs and I hand you something that looks like this, you'd kind of guess, okay, there's going to be a little menu thing. You open it, it does this. You click continue, it closes and it goes back, right? And that sort of loop. But what if you could use the power of AI to just make it, just do it for you? So this is Make Real. This went viral in 2023 when all the new multimodal vision models came out. And that's basically it. Like the prompt is, hey, you're a 4,000-year-old senior developer. There's a asteroid heading for Earth. The only way to solve this is to develop perfect user interfaces for the designers that you love. Um, and it just does it. I mean, it just makes the stuff, right? And I mean, really, you could do this yourself. Take a screenshot of a drawing or something, put it into a chat, and do it. But you might notice that this is a working website that is on the canvas. I can kind of like resize it and rotate it. I can even draw on top of it, uh, which means I can do stuff like make this green and kind of annotate on top of it. And then, in the same way that I just selected, oh, that's interesting. Uh, we'll see if that's a problem. In the same way that I selected this stuff in order to make this, I could just do it again and include my annotations, and it would use that as the new prompt. And you can just keep going and going and going with this stuff, and pretty soon you have, I don't know, just the entire uh, applications that use the camera that do stop motion animation, things like that. Um, and I'll let this go, right? So cool. Blah, 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 right? Nice. Got that right. I made that by just drawing it. Hooray. Cool. And then I don't know, maybe it did it, maybe it didn't, but hey, yeah, and it's green. So some of those are the kind of AI demos that you might be interested in. Um, but first we need the canvas, first we need the collaboration, and big thanks to DOs for making that much easier and much more possible. Thank you.
If any questions, for Steve or Natalie?
Do you want to come back up? No? Okay, I'll answer on behalf of Natalie as well. Shoot. For the collaboration? Yeah. Um, we fuzz test the engine, and then we trust that WebSockets work the way that they should. Is that accurate, David? Yeah, that's accurate. In other words, like the protocol, like if there's a problem with that, then that's deeply problematic. But most of the problems that we get have to do with things being handled in the wrong order, or just some weird edge case where we're unable to um, roll back and things like that. Yeah. Cool. Yeah. Shoot. Per collaboration session. So if I'm collaborating on a document, that document gets a worker associated with its ID. If other people join that document, then they join and connect to that same worker. If you fork it into a different document or something, that would get its own worker as well. So it's the ID of the room that is sort of like the key to um, which DO exists. Yes, everyone is connected. I think if I'm understanding the correction, yeah. Cool. I think we have like a soft limit of 50, but there really isn't any. We could try. How many people do we have in the room? I'm tempted. Let me give me a second. A lot. You can have a lot. I mean, like you're really only limited by the compute of the worker, which is yeah, and the durable object, yeah, and the memory of the durable object, which always seemed to kind of like be gradually going up. So that's yeah, and theoretically unlimited number of users per room, but practically we like cap it at 50. Yeah. And you can do different things. If it was critical to have 100,000 people participating, you switch to polling, you use, read only rather than write only. At one point we were applying a spring-based simplification or interpolation to our cursors. And we realized that the limit to collaboration was actually the compute, like on the user's client to do that interpolation, or like, oh, our thing is fast enough now we can drop the interpolation and that unlock that raises the ceiling. So it's funny to see where these kind of limitations occur. Did you have a question?
You have a here. You use a breakpoint for the
The DOs, yeah, they die and then they wake back up whenever someone reconnects to that room. If you wanted to have uh, a, a script that opened 100,000 tabs in your browser and iterated through them all and clicked the mouse button or did something that kept you active as a user, yeah, you'd have 100,000 active DOs somewhere. We don't know how much Cloudflare costs. We've been in the startup program, so someday I'll get a bill, but nothing yet. In general, though, this is very affordable. Um, yeah, compared to having a ton of load balanced servers that often, like when we talk to people who do this the old way, you need to have, because of how spiky collaboration can be. Um, you need to kind of have enough provision to handle the maximum at any given time, just because the process of spinning up those servers and doing replication, if that's necessary, all this stuff is like really high and takes a long time. So if you do want it to be like, hey, jump into my project and guarantee that experience to be good, it is, yeah, you end up having way more capacity at any given time than you're actually using, which is much more expensive. So yeah, on demand is cool. Hey,
Hey, so you had a little green database that you consistently stick to. Is that structural sort of refinement? Yeah.
well, the yes and no. I mean, the DOs have database like per DO. Um, I think there's multiple. There's SQLite database, which now has like 10 gigabytes per DO, which is crazy. Um, but for us, there's various reasons why we do that. Really, when you're using Tealdraw, every 10 seconds or 30 seconds, maybe 10 seconds, we just bang it, just serialize the entire state of the board and just chuck it into R2 as its own file. And so for, certain popular rooms, for like our retro room or whatever that we've used, board that we've used for months, like there's probably thousands and thousands of copies of that, all 10 seconds, separated. We do that because it's actually just like it's fine. Um, but I also have questions about, can we, like, what can we learn from that? I mean, telling a story about what happened in a room, giving a user the ability to travel back in time to earlier parts of the board. Um, there's a lot. I don't know. There's enough reasons to keep that data rather than be overwriting the same file or something like that. Um, and yeah, we need to pull that data from various places, not just the DO. So it's kind of just an artifact of our own requirements, our own. You could absolutely be sticking that into the SQLite database. I guess.
the making then hesitate the is the time. There was the
Okay, yeah, I guess. I don't recommend it. I don't know. Um, it is not. I mean, it's a demo. First off, it's a pretty cool demo. And people have used it to make really interesting games and things like that. But the my hope as a person who sells the canvas to developers would be that you'd say, oh, that would be perfect for designing storefronts for my little, something like that, right? Um, the the thing that I normally do is that you squish the possibility space and the quality goes way up. With Make Real, the possibility space is infinite. We don't tell it what its job is other than making websites. So the quality tends to be low. We're not saying only use this component library, only use this color scheme, only do this. We're saying do whatever you want. Just do it whatever the user asks for. Um, but yeah, I mean, you can download the code. You could open it in Replit or StackBlitz and play around with it. We decided, actually, Misha here added a code editor to Make Real, at one point, and then we decided not to ship it because it kind of took the fun out of it, to let you actually mix your own code with the stuff that the AI was making. Um, but yeah, good. Hey,
For the web socket authentication in your EFC, could be using something like party kit or part servers structure.
Party Kit was unofficially incubated at Tealdraw. I contracted Sunil to solve my problem of how do we deploy WebSockets, and he wouldn't shut up about his new idea about using these durable objects to do it. And so he built it. It was amazing. And then he started a startup, and we shared an office until he went back to Cloudflare. So yes, there's a lot of relationship between that project and Tealdraw. I think he pitched the company by just showing people Tealdraw and be like, look, look, look at how fast this is. Yeah. So happy to help. Cool. I give it back to you, Ricky.
Yeah, I have perfect timing. One more round of applause for Lee. That's law. I should have like a conclusion, but we are now concluded with this session. Enjoy the rest of Connect.